So hello guys, in this video we are going to solve another example of non-homogeneous differential equation using the method of undetermined coefficient. So we have here another example, d cubed plus d squared minus 4d minus 4 times y is equals to d times e raised to negative x minus 4x minus 6. So first, we are going to solve for the complementary solution of this differential equation. So in solving the complementary solution, we are going to first transpose this into a homogeneous differential equation. So this will just equate this into 0. D cubed plus d squared minus 4d minus 4 times y is equals to 0. And the next is we are going to solve for the roots. So we will change d into m. So this will be m cubed plus m squared minus 4m minus 4 is equals to 0. And then we will use the synthetic division in getting the roots. So we will write the constants of the terms here. So 1, positive 1, negative 4, and negative 4. And then first we will try to use positive 2. So this will be 1 times 2 is 2, 1 plus 2 is 3, 3 times 2 is 6, 6 minus 4 is 2 times 2 is positive 4 and is equals to 0. Therefore, our first root is positive 2. And then we will write this, and then we will write this m and then reduce the exponent. This will be m squared plus 3m plus 2 is equals to 0. So we can factor this out, this polynomial. So this will be m plus 1 times m plus 2 is equals to 0. So the roots of this polynomial is are m sub 2 is equals to negative 1 and m sub 3 is equals to negative 2. Therefore, our complementary solution will be y sub c is equals to c1 e raised to our first root, which is 2x plus c2 e raised to negative x, our second root, plus c3 times e raised to negative 2x. This will be our complementary root. Next is we are going to solve for our particular solution. So y sub p is equals to, we'll base our y sub p in this equation. So this will, our y sub p will be a e or ax e raised to negative x. Since negative x is already in our complementary solution, so we will add x here, minus bx or plus bx plus c. And the next is we will derive our y sub p until we reach the higher order of our differential equation. So y prime of p is equals to, this will be negative a x e raised to negative x plus a e raised to negative x plus the derivative of bx is b and the derivative of c is 0. So we won't write this. So the second derivative of our y sub p will be derivative of negative ax e raised to x is ax e raised to negative x minus a e raised to negative x minus a e raised to negative x, and the derivative of b is already 0. And they will combine like terms, so this will be ax e raised to negative x minus 2a e raised to negative x. And then the third derivative of y sub p will be negative ax e raised to negative x plus a e raised to negative x plus the derivative of negative 2a e raised to x is 2a e raised to negative x. And then again combine like terms, negative ax e raised to negative x plus 3a e raised to negative x. And the next is we will substitute the values of our derivatives in our differential equation. So we'll rewrite our differential equation d cubed plus d squared minus 4d minus 4 is equals to 3e raised to negative x minus 4x minus 6. So our third order of the derivative is negative ax e raised to negative x plus 3a e raised to negative x, and d squared is this, so plus ax e raised to negative x minus 2a e raised to negative x minus 4 times our d, which is this negative a x e raised to negative x plus a e raised to negative x plus b minus 4 times dy sub p a x e raised to negative x plus bx plus c is equals to this, and equate. Next is factor what's inside the parentheses. So we can write this negative ax e raised to negative x plus 3a e raised to negative x plus ax e raised to negative x minus 2a e raised to negative x plus this will be 4ax e raised to negative x minus 4 a e raised to negative x minus 4b minus 4ax e raised to negative x minus 4bx minus 4c is equals to, and equate in our function here. And next we can write this a e raised to negative x times the constants of the a e raised to negative x. This will be negative x plus 3 plus x minus 2 plus 4x minus 4 minus 4x minus 4b minus 4bx minus 4c is equals to 3e raised to negative x minus 4x minus 6. And then we can cancel this out. So the value of a3 minus 2 minus 4 is negative 3, and then we will equate this into the constant of e raised to negative x here. So equals to 3, and the value of our a is negative 1. And then to get the value of our b, our negative 4b, we will equate this into the constant of the negative 4x here. So this will be negative 4b is equals to negative 4, and b is equals to positive 1. And then the value of c will be the negative 4b here, and minus 4c is equals to the constant here equals to 6. So we can substitute the value of b, negative 4 times the value of b here, which is 1 minus 4c is equals to 6. So this will be negative 4 minus 4c is equals to 6. And then negative 4c is equals to 6 plus 4. Oh, sorry, this will be negative 6. Negative 6 plus 4. So this will be negative 4c is equals to negative 2. So the value of C, of our C, is equals to negative or positive 1/2. Therefore, our y sub p is equals to, our y sub p here, we'll substitute the values, negative x e raised to negative x plus x plus 1/2. And then to get the general solution, y is equals to y sub c plus y sub p. So our y sub c is c1 e raised to 2x plus, we can rewrite this c2 e raised to negative 2x plus c3 minus x times e raised to negative x plus x plus 1/2. And this will be our general solution for this differential equation.